Hi, welcome to my last part or part 6 of my series on parametric differentiation. I have a question here that says, or a statement that says, the diagram here shows the curve with parametric equations, or x equals to 2 minus the cosine of 2t, y equals to 2 sine cube t plus 3 cos cube t plus 1, and t being an angle that is between 0 and pi over 2 radians. The endpoints of the curves are given to you as 1, 4 and 3, 3. We have to find dy dx. Now, let us see. We're going to have quite a lot to do with this one, so let me just make sure I collect these two so I can have it. Okay, so they say part A, find dy dx. Good. Yeah, let's start. So x is equal to 2 minus the cos of 2t. Then dx dt will be, the derivative of that is obviously going to be 0, and the derivative of cosine is minus sine of 2t times the derivative of 2t, which is just 2. So at the end of the day, this gives me 2 sine 2t. Okay, so that takes care of that one. The one that is going to be a little bit more work though is y. Y equals 2 sine cube of t plus 3 cos cube of t plus 1. Well, I'll spend a bit of time with this one here. So what I'm going to do is I'm going to divide them into two parts. So I'm going to find the derivative of sine. So let me say this is going to be my side work. My side work 1. So we're going to find the derivative of sine 3t, the derivative of sine cube of t. So let me say, let this equal to u or y. Because remember, this is the same as y equals to sine t all cube. So from here, I can then also say that perhaps u equals to sine, what is it, sine t, the stuff inside. Then that will therefore mean that y equals to u cubed. Okay, so here du dt will be, the derivative of sine is cos t. Then here I will have dy du, which is 3u squared, which we know u to be sine t, so that's going to be 3 sine squared t. Then from here, dy dx will be dy du, which is 3 sine 2t multiplied by du dt, which is nothing but cos t. Now, this is the derivative of this baby over here. So I'm going to rewrite that one. Okay, let's do another one, because I want you to have a look at the way y is given. You've got sine cube t. Now I'm going to do cos cube t. Okay, I can use the same stuff just so I can know what is it that I need to eventually carry. So let's say we now calculate y equals to cos cube of t. And then we say, what if we rewrite this as y equals to cos of t all cube? Then we have y equals to In fact, let us just say we're going to bring in u now. We're going to have, say, u equals to cos of t, and we have got y then will be equals to u cubed. Here we go. Du dt will be, the derivative of cosine is minus sine t, which is just minus sine t. Then dy du will be equal to 3u squared, which is the same as 3. What is our u? Cos squared t. Okay, it's going to be 3 cos squared t. Right, so now I can join them. Dy dx for this particular one, it's going to be 3 cos squared t, and we're going to multiply that with minus sine t. So I can just as well clean it up a little bit. It's going to be minus 3 cos squared t sine t. I think I have done the bit that I could do in order for me to have, my values correct there. So at the end of the day, if I was to write from the original equation, okay, from the original one, so let's just bring our original one as it was. Let's just bring y back. Take a snapshot of my y, bring it down, because there's a lot that it's sort of, it goes from here. So if I have to find dy, if I have to find dy dx, it's going to be 2, then the derivative of that plus 3, the derivative of that plus 0. Now, we know from our work that I've just done, I know what the derivative of this one is. Now, that one's derivative, sine cube of t, sine cube of t is all the way here. So I'm just going to bring it as this one that I've worked out. So I'm going to bring it and I'm just going to insert it over here and hope it can fit. Okay. What else do we know? We know that the derivative of cos cube of t, cos cube of t is this one over here. So I'm going to grab that one also. I'm going to grab that one also. So it's going to be here. Right. So this is going to be dy dx. So we can just go ahead and clean this up. And if we clean this up, eventually we're going to have 6, because that's 2 times 3, sine squared t cos of t, okay, then minus 9, 3 times 3, cos square of t sine t. Okay, this was not dy dx, but let me just make sure it's dy dt. So just make sure that I don't mess up this whole scenario. This was dy dt. This was dy dt. Now that I have dy dt, what is going to be, so I know what dy dt is, right? So let's find dy dx now. It's going to be this dy dt, which is 6 sine square t cos t minus 9 cos square t sine t. All of this is going to be all over Now, if you remember, what was our very first one from the beginning, before there's a lot of side work, our very first one was dx dt. Dx dt was equal to that. So obviously here is another one that goes, if this is dx dt, then what this one essentially is, this is going to be, if you have to find dt, dx is going to be 1 over 2, okay? That's going to be 1 over 2 sine of 2t. This is what I'm going to bring down, 1 over 2 sine of 2t. Okay, right. Let's go back all the way. So that's 1 over sine, that was 1 over 2 sine of 2t. Right, we're not totally done yet. We do realize that they say our dy dx is supposed to be something like this. So let me just grab it. So our part A, what is it that we need to show? Because we need to get to this. Okay, it's a lot of work, but it has to be done. Once you know what you're doing, you really don't have a problem, and you have to be careful as you see how I navigate through the problems. Okay, so this is what eventually I need to show. So I have a problem here with my 2t, which I will definitely write using my double angle. It's going to be 6. Maybe I'll put cosine of t, and then I put sine of that first, minus 9. Similarly, I'm going to say sine of t and cos of that. So all of this is going to be, and this is the part that I'm now doing, and I'm going to write it here on the side, that sine 2t is equal to 2 sine t cos t, if that is the case, right? So if this here becomes 2 sine t cos t, and if I multiply that by that 2, I'm going to get 4 sine t cos t. Hope that makes a little bit sense, right? Okay, good. On top, we can actually take out common factor. When I look at what is common here at the numerator, I've got a 3 that is common. I've got cosine of t, sine of t that is common. And I'm going to be left with 2 sine of t minus 3 cos of t, if you look at that, okay? All of this will be over 4, well, sine t cos t. Now, what is it that we have? We can see that from our work here, this cosine and that cosine is cancelling, this sine and that sine is cancelling. We are left with a positive 3 over 4. So maybe I need to append the page here. Page, append. I'm going to append actually about 2 of them, no problem. So we are now left with, it's also safe because this work is kind of important that we don't lose it. Okay, what we are left with eventually is 3 over 4. In brackets, I have 2 sine t minus 3 cos t. Okay, I just want to quickly see what is it that we needed to get. So I'm going to grab that. Just bring it down over here. Right, so yeah, let's multiply out. If we multiply the numbers, we have 3 over 4 times 2, okay, that will be sine t minus 3 over 4, okay, times 3, that will be cos of t. Now let's see what we have. Well, you have got, if you have got this 2 over 1, 2 goes there. This is 3 over 4 times 2 will give you nothing but 3 over 2. That is sine t. 3 times 3 is 9 over 4 cos t. This is our dy dx, and it corresponds to what we needed to show. Okay, corresponds. You agree? There we go. So that our derivative function. That was part A, can you believe it or not, of the question. This is what we ultimately had to show. So you had to be a bit careful with the algebra. So let's go back all the way. I hope you realize how I did my thing step by step and so on. So they want us to find B. They are saying find the coordinates of the minimum point, giving each to 3 significant figures. So the minimum point is the point where dy dx is equal to 0, or the gradient that we have just calculated is equal to 0. So dy dx, okay, when you look at part B, the minimum point, this one, the minimum point here that they are referring to, this is where dy dx is equal to 0. Okay, so occasionally what that now means, we'll be taking our gradient function, which is 3 over 2 sine of t minus 9 over 4 cosine of t, and we're going to let that equal to 0. Totally up to you how one has to go about this business. Maybe, again, as I say, we can say 3/2 sine of t is equal to 9 over 4 cosine of t. Then if I was to divide throughout by the cosine of t, I can actually have a different trick altogether. That will be 2/3 of the tangent of t is equal to 9 over 4. Then I can isolate my tangent of t. Tangent of t will be that 9 over 4. Well, I'm just going to multiply it by the inverse of that times 3 over 2. At the end of the day, if you do that, you have times 3 over 2. Am I right? So, if you do, you're going to have that 10t, the tangent of t, let's just make sure of it. Here I had 3 over 2. See, 3 over 2. I think I have messed up a bit. I was wondering. This was 3 over 2 over here. This was 3 over 2. And when I multiplied by the inverse there, that's why I was so quiet. I was wondering what is happening. When I multiplied by the inverse there, the inverse of 3 over 2 is nothing but 2 over 3. Now that makes a little bit more sense because 3 goes there 3 times and so on. So this is 3 over 2, which is something that I can calculate for the value of t. Then this will give me that t will be the inverse of that, which I'm going to grab my calculator for. Okay. So if I grab my calculator, see what it gives me. The inverse of this 10 inverse of 1.5. You just say 1.5. 1.5 is nothing but 3 over 2. Okay, good. So this is the ratio I'm looking for, or the value I'm looking for. Now, remember, we are supposed to calculate the coordinates of the minimum point. Okay, then we give those things where x is equal to. So to three significant figures. So what was the equation for x and what was the equation for y? So let us just go grab my two original equations as it was. And I think I wrote them somewhere over here. Then I took a picture of them. Well, you can just go back. I know I'm going back and forth, but you just follow. Right, this is what I'm looking for. So let's just copy this. And I'm looking for the two values, these two equations, when x is this and y is equal to that, okay? That's what I'm looking for, right? So we now have the value of t. Since we have the value of t, we can actually now determine what the value of x is, and ultimately also what is the corresponding value of y. So when t is equal to that, so x is going to be equal to 2 minus the cosine of t times this whole 0.98279 and so on and so on. That will give me something. And then y will equal to 2 sine of that 0.98279 dot 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 dot. This is going to be cubed plus 1 at the end. Okay. Now, if you were to calculate it, I did. This one is going to give you 2.3. Okay. You can always do it on a calculator and see if you do arrive at the same solutions as I do. So that's 2.3846 and so on. And this one is going to give you nothing but 2.6641 and so on. So the coordinate of the minimum point, okay, the coordinate of the minimum point to three significant figures, or did they say four significant figures? Okay, just make sure what they said at that particular question. They say give this answer to three significant figures. Okay, cool. Three significant figures. It's going to be 2.38. And this one is going to be 2.66. Right. There we go. Those are the solution. And we are good to go. So that took care of our answer for part B of the question. What is part C asking us? Since I think there is a part C. So let's just go ahead and go get that question as well. Go back all the way to get part C. Part C says find the exact gradient. Oopsie. The gradient at the point which x is equal to 2. Right, the keyword being exact there. So we are going to do part C all the way over here. I think it can fit. Find the exact gradient. What was our gradient? Our gradient function. Well, our gradient was, you can just as well bring it. I'm going to bring it all the way over here. They say we find our gradient function when x is equal to 2. So when x is equal to 2, this is not really what I'm looking for. Okay. Find the exact gradient of the normal to the curve. Okay, so before we do that, okay, actually we can bring that, I can keep that, no problem. Before we can do that, let's say when x is equal to 2, remember our equation was 2 minus cos of 2t. Now if it's equal to 2, then I have minus cos of 2t is equal to 0. Then I have cos of 2t is equal to 0. Okay, then of course there's one more thing that I need to consider as one will now bring a calc function, something we need to consider. What is the domain of this? Our domain is from 0 to pi, half pi radians. Good. So the cosine function normally starts. It normally starts over here. Then it will go. Okay. Then it will go like so. So this point here is that point. That is 1. This is going to be x. That's going to be y. So in this particular case, our angle 2t, will equals to pi over 2. Therefore, if that is the case, because at that place here, we have got the y value is equal to 0. So that implies that t is pi over 4. That is if you divide throughout by that. Okay, so we have our pi equals to what our value now when we have our value as far as that is concerned. Now, what is it that we also have to consider? Well, let us just consider of maybe appending some pages in there. It's getting a bit late. Maybe I'll bring in 2 just to make sure. Right, what do we know? We need to find the exact gradient of the normal. So, one, we have to find the gradient of the tangent. That would be 1. And how do you find the gradient of the tangent? Well, this happens at dy dx. You just go get it. This happens when dy dx is when x is equal to 2. That is 3 over 2. Then you have sine of pi over 4 minus 9 over 4 cosine of pi over 4. Okay, now there is going to be so much that you can do. You can actually use your calculator at this particular point. It's going to be 3 halves. Now if I deal with this from special triangles, I hope you still remember from special triangles, it's not to scale, but if this is pi over 2 radians or 90 degrees, this is pi over 4. This is also pi over 4. That is 1 and that is 1, and this is the square root of 2. So if you calculate the sine of pi over 2, the sine of pi over 4, the sine is 1 over that. It's the same as 1 over root 2, which can actually rationalize. The cosine of that is the same. It's 1 over root 2. Let's just clean it up, okay? So that's 3 over 2 multiplied by root 2 over 2 minus 9 over 4 multiplied by root 2 over 2. Of course, that is you rationalizing that denominator. I mean, you're going to get root 2 over 2. Okay? Again, you can use your calculator. You will definitely get to the answer. So this is going to be nothing but 3 root 2 over 2 minus 9 root 2 over, this is it's not over 2 though, we are multiplying numerator of numerator and denominator of denominator, so this is going to be over 4 and this is going to be over 8. Right, so let's see, what is the LCM? Oh, the LCM is just going to be 8, so everything over 8. that means you're going to multiply this by 2, and you're going to multiply that by 2. That is going to be 6 root 2. This is going to multiply by 1 minus 9 root 2. Of course, at the end of the day, 6 minus 9 is negative 3 root 2 over 8. There we go. Right, we can also now look at what is the equation, or what is the gradient of the normal. This is the gradient of the tangent, so the gradient of the normal will be, the gradient of the normal, okay, will be, just switch this around, the 8 comes on top, and 3 root 2. Okay, no negative sign anymore. Of course, let me just clean it up by multiplying numerator and denominator by root 2 in order for me to rationalize that. That is going to be 8 root 2, and that is going to be 2 times 2. Okay, now remember that the root 2 times root 2 is just 2, so this here will become 3 times 2, which is nothing but, if you were to look at it, you're going to get this 2, okay, goes in itself once, it goes here 4 times, so at the end of the day it's 4 root 2 over 3. So this is the gradient of the normal. Okay, took you some time, this next, to get it, and that's what they were looking for at the end of the day. They just said, from here they said, find the exact gradient of the normal, and that is all. Find the exact gradient of the normal to the curve. Right, and that is the exact gradient. Now, of course, you could have used a calculator in so many ways, especially if you are not so familiar with the special triangles that we are using in order for us to find unknowns. Again, as I said, you have the luxury of using a calculator in the examination, so use it as long as you know what is it that you are doing. All right, that brings me to the end of this series on parametric um, differentiation. I hope it will assist you and give you a hint as to how to approach these types of questions.